Chapter 15, Problem 4. The following data was collected for the reaction A goes to products. Part A, what is the rate law for the reaction? So in all three graphs, they're plotting time, but then we could see on the y-axis, we've got concentration of A, ln concentration of A, and 1 over concentration of A. Now, the only thing we care about is the linear plots. So you should get a linear plot for 0 order if it's concentration of A versus time. If it's first order, you'd get a linear plot if it's natural log the concentration of A versus time. And lastly, second order, if it's 1 over concentration versus time. So looking at the three graphs here, we see there's only one linear option, which is plotting 1 over concentration of time. So we're looking at a second order for compound A. So my rate law should have K concentration of A squared. Part B, what is the rate constant? Well, we can get the rate constant from the equation of the line. So the equation of the line is 1 over concentration of A equals the rate constant times the time plus 1 over the initial concentration of A. Now remember, the equation of the line is y mx plus b. So what we could see here is that K, our rate constant, is the same as the slope. Now to get a slope, remember you do change in y over change in x. Now it's completely arbitrary which 2 points you pick on your graph. So I'm going to pick the first point and the last point for no reason whatsoever. So if I look at the first point, it falls on 20. If I look at the last point, it falls on 70. This is y, of course. Now, if I look at x, the first point is at 1 second, and the last point is at 6 seconds. So my slope, if we look at the top, it's going to be 50 over 5 is going to be 10. Now, I forgot to write down the units, but since this is 1 over concentration, then this should be molarity to the -1, molarity to the -1, and these should be seconds. So I should have molarity to the -1 and seconds to the -1. Part C, what is the concentration of A after 7.3 seconds? So I'm going to use the equation of the line again. So I'm going to use this equation here. So we're looking for the concentration of A. I know the slope. I just calculated it. And they're telling us the time is 7.3 seconds. Now, initially, that should be the y-intercept. So if you extend this line down, the y-intercept is 10. So if we solve for A, we get 0.012.